Welcome to the Vodcast presented by Group 23, where we will be explaining about the XY plane using the demand and supply function as our model. The XY plane is called the Cartesian coordinate system, which was invented on the 17th century by René Descartes. Plotting quantities on a graph, we use real numbers, which can either be positive or negative, and can also be represented as a decimal expression. The xy plane provides axes that are not perpendicular to each other. A point on the x-axis is called the x-coordinate, and the point on the y-axis is called the y-coordinate. The whole plane is called the xy plane, and the point where the axis is cut is called the origin. The axes of a two-dimensional xy plane divide the plane into four regions called quadrants. These are numbered starting with the top right quadrant and moving around anticlockwise. A function is a rule that associates with every real number x precisely as one real number y. For every function where y is given as a formula in x can be represented in a graph by plotting the coordinates accordingly. In our model in this vodcast, we have used the demand and supply function example to give a further explanation about the xy plane.
Now I'm gonna present to you about the economic concepts that related to the XY planes. The first thing is the demand function, which presented as Q equals to the function of P. In this function, Q is called the quantity and P is the prices. This is a simple method to reflect the demand curve on the coordinated plane. Another function that is the inverse function of the demand function is the supply function. Can be presented as price equal to A times Q plus B, with A and B are the variables and A and B are both positive required. The supply functions presents the relation between the quantity and the price of the good. Now I'm going to give you a brief description about the model on the XY plane using the demand and supply function mentioned above of a pizza restaurant. In our model, the demand and supply functions explain the consumer behavior and manufacturer behavior in accordance to the price of the product or service and the quantity of the product and services. The model uses a demand function as price equal to the quantity demanded. In this example, quantity Q is the independent variable and demand function represents the price P that consumers are willing to pay at that quantity. The supply function states the similar results. Our model describes the relationship between price and quality for a regional pizza restaurant.
The demand function for pizzas is dq equals minus 3q plus 25, where q is the number of pizzas sold in thousands. The supply function for the pizza restaurant chain is sq equals 2q. To find the equilibrium point for the pizza chain restaurant, we will have to solve both the equations simultaneously. Therefore, dq equals minus 3q plus 25 is our first equation, and sq equals 2q is our second equation. If we then solve sq equals dq, we get sq equals minus 3q plus 25. If we then take our q derivatives to one side, we get 5q equals 25. If we divide 25 by 5, we get our q to be 5. Putting the value of q into equation 1, we find the value of price in equilibrium point. Therefore, dq equals minus 3 into 5 plus 25, which gives us the value of price is 10. To cross-check if the value is true for the supply function as well, we put the value of q in equation 2, which is sq equals 2 into 5, which gives our price to be 10 as well. From these values, we can sketch a graph of demand and supply with price in the y-axis and quantity in the x-axis as shown in the graph.
In conclusion, it can be said that from the graph above, we can see that the equilibrium point is at 510, which has been proven both algebraically and graphically. It can also be said that at a price of $10 per pizza, the quantity demanded by consumers is 5,000 pizzas, and the quantity the pizza chain is willing to supply is 5,000 pizzas. Well, there are both ethical issues and environmental factor. The ethical issues are employers and employees must be careful when storing or handling food, be strong in including food safety and code of ethics, and must be familiar with suppliers. And the environmental factors are boxes should be made of 100% recycled material and no intensively breeding of livestock and less deforestation. Thank you so much for your attention.